In this video, we're going to see what happens if we have two groups that are tied when we're trying to figure out the priority. So this can happen when you have two of the same atom attached to the chirality center. So first, when we're going to name this as RS, we have to identify the chirality center, which is this carbon here because it's attached to four different groups, a hydrogen, a bromine, a CH3, and an ethyl group. So that's our chirality center there. What the first thing we can do is assign the priorities to atoms that are not tied. So if we look at what's around our chirality center, we see that we have a bromine, a hydrogen, and then two carbons attached. Although they're part of different groups, which is why it's a chirality center, we still have the two carbon atoms tied. And so what we can do is we can take a look at bromine and hydrogen. Bromine has a higher atomic number than anything else attached, so it has a higher atomic number than the carbons or the hydrogen. And then hydrogen also has a lower atomic number than anything else attached. So it has a lower atomic number than the carbons or the bromine. And so automatically with the priorities, we can say that bromine is going to be number one, and then hydrogen is going to be number four. So that's how we're assigning those priorities, so we can kind of transfer them down to this step here. Once we do that, we at least know what two of the priorities are. We do need to then look at the atoms that are tied, and we have to keep going along those chains. So one of the things we can do, so the two atoms that we're going to look at is this carbon here and this carbon here. It can be a good idea to draw out all of the hydrogens. So let's go ahead and draw all of the hydrogens on the carbon on the left and also on the right. And we're going to call the carbon on the left carbon A, and then on the right is going to be carbon B. And then we're going to do a little comparison for A and B. And what we're going to compare is what do we reach after we get to this atom. So going out from the chirality center, we get to a carbon in this direction, we get to a carbon in this direction. Now we have to think about what else is attached after that point to start to break the tie. So we're going to keep moving along this chain until we get to the first difference. So if we get to this carbon, we see there's an H attached to it. Same situation over here. We have an H attached to the carbon, so we can go ahead and write down that we're going to get to an H in both directions. So we've already counted, let's say, this H and this H. So when we get to keep going, we're going to hit another H if we're going off of this carbon. Here, same thing, we hit another H. And so we can go ahead and put those H's down. And what we're doing on the right is just comparing what atoms we're getting to when we're walking along that chain. Now we're going to have the same carbon, so we've already counted two H's off of this carbon, the two H's off of this one. So the last thing attached to this carbon is another H. The last thing attached to this carbon is a carbon, so it's a CH3 group or a carbon atom. So that's going to be our difference. So when we get to A, we just hit three H's. When we get to B, we hit two H's and a carbon. And so that's going to be what we're going to focus on. So A had the H, B had the carbon. And so for the priority wise, because we get to that first difference right here, and the carbon has a higher atomic number than the hydrogen, that's going to make that whole chain of B a higher atomic or a higher priority because that one has a higher atomic number. So that makes that whole chain higher priority, which in this case, B is going to be priority 2 because that's our next priority. So we already put bromine as 1. So that means that the ethyl group is going to be priority 2, and then priority 3 then would be the methyl group on the left-hand side. So that's going to be priority 3. So again, what we did when we went to the tie is we started to look at the atoms that are attached. We kind of did this one at a time, but you can also go there to this carbon A, for example, and be like, okay, it's attached to 3 H's, and then go to carbon B and say, well, it's attached to 2 H's and a carbon, and so this is higher priority. You can do it that way as well. We were just kind of doing it stepwise, one at a time. So that's going to give us our priorities. Next, what we have to do is rotate so that priority 4 is in the back. It was already in the back, and sometimes this happens, and so you don't actually have to do a rotation. You can just take a look at the order of the priority. So here we have we've kind of redrawn it, looking at it with all of the groups 1, 2, and 3 in the same plane. For once 4 is in the back, we ignore 4, so we don't have to worry about that one. What we're doing here is we're going from 1 to 2, 2 to 3, 3 back to 1. What direction we're going in is a clockwise direction. And so this is going to be an example of an R enantiomer. And how this would play into the actual naming overall of the molecule is that the R is actually, or the R or S, depending on what the enantiomer is actually listed in the very front of the name in brackets. So this compound would be called R, and then there's a dash to separate because we're going to put a number. Our chirality center is actually on carbon 2. If we counted out the carbons, carbon 1 would be this one, carbon 2 would be this one, because it's the carbon 1 is the closest one on the chain to this actual group coming off. So carbon 1, 2, 3, and 4. So since the chirality center is on carbon 2, this is what we're going to put here. And then it's bromobutane. Bromo because we have a bromine, and then butane because the chain is 4 carbons long. If we had multiple chirality centers, we would just have to put, like this would be 2R if we had something else on 3. So we put 2R and say like we had another group here that was maybe an S configuration. We could put 2R, 3S, and that is in brackets, and then the rest of the name. So you basically identify whether it's R or S at the very beginning of the name. And if there's more than one chirality center, you do also have to associate the R and S with what chirality center, what carbon number is that chirality center on, and which carbon number is R or S. So that's kind of how it factors into the name. In the next video, we're going to take a look at what if we have multiple bonds present attached to that chirality center. So maybe down the chain somewhere we have a double bond or a triple bond. How do we deal with that?